Students of class 9B, in this video class of geography, our chapter 14 atmospheric pressure and winds are continue. As you have seen in the last video class, there are 5 types of pressure belts. Those are equatorial low pressure belt, subtropical high pressure belt, subpolar low pressure belt, and polar high pressure belt. There are 4 types of pressure belt. Pressure belt depends upon few factors. So today we will discuss those factors responsible for the development for pressure and wind belts. The first factor is the amount of insolation. Means the how much amount of solar radiation is received by the earth, that also defines the pressure belt. Second, the rotation of the earth and the revolution of the earth. These 2 factors are responsible for the location of the earth regarding the sun. Sometimes the sun remains in northern hemisphere, sometimes sun moves to the southern hemisphere, and due to this movement of the sun, the amount of insolation is also affected. Suppose the sun is in the northern hemisphere, then the southern hemisphere will get less amount of insolation. That in that situation, northern hemisphere will experience low pressure belt and the southern hemisphere will experience high pressure belt. And in changing the location of the sun regarding the earth, these 2 factors, the rotation of the earth and the revolution of the earth, these 2 factors are involved. As the sun changes its location regarding the earth, then amount of insolation is also affected, and due to these reasons, the pressure belt also differs from latitudes to latitudes. So first, we will discuss this pressure difference regarding these 3 dates. The first is 21st June, second is on 23rd December, and third is on 21st March and 23rd September. Regarding these dates, the location of the sun is changed regarding the earth. On 21st June, the sun rays fall vertically above the Tropic of Cancer, and all the pressure belts shift northward except the high pressure belt of polar region. Therefore, between 0 degree to 10 degree northern latitude, low pressure belt is found, and this date on 21st June is named as summer solstice. Here on Tropic of Cancer, vertical sun rays fall, that shifts the pressure belt northward except the high pressure belt of polar region. On 23rd December, the sun remains in the southern hemisphere. The sun rays fall vertical between 0 degree. The sun rays fall vertically upon the Tropic of Capricorn, and between 0 degree to 10 degrees south, low pressure belt is found. All the pressure belt shifts to southward except the high pressure belt of polar region. So on 23rd December, the sun rays fall vertically above the Tropic of Capricorn. So this date, 23rd December, is named as winter solstice. Now we come on 21st March and 23rd September. During these 2 dates, the sun rays fall vertically above the equator, and there is equatorial low pressure belt. These 2 dates, 21st March and 23rd September, these 2 dates are named as equinox. Here, other things are also related with the summer solstice, winter solstice, and equinox. On summer solstice, the day is the longest and the night is shortest. On winter solstice, the day is shortest and the night is longest. But on 21st March and 23rd September, the length of the day, means the duration of the day and the length of night, both remains same. So all these longer days, shorter days, longer night. So all these are given only for northern hemisphere. So in this, we saw the factors responsible for the development of pressure and wind belts. Those are three. Due to these different pressure belts, we see this different pressure belt through these 3 dates: 21st June, that is named as summer solstice; 23rd December, that is named as winter solstice; 21st March and 23rd September, those are known as equinox. Thus we saw the different pressure belts on the earth, those are 4. After that we saw the factors affecting the pressure belts and winds, those were 3. And now we'll see the direction of the winds and speed of the winds. These two are affected by different factors. Now, as here wind, the word wind is coming, for that the definition: the horizontal movement of the air along the surface is called wind. And just after that I have written air current, because the definition is just opposite. Here is the horizontal movement of air, that is called wind, but here is vertical movement of air, that is called air current. So I have written this together. Now the movement of air, that is defined by the air pressure. Always the winds move from high air pressure to low air pressure. This is just the movement as the oceanic water. As the oceanic water moves from high temperature to the low temperature belt, similarly, the winds move from high pressure belt to low pressure belt. And in this movement, few factors are involved. Those are responsible to determine the speed and direction of the wind. The first is pressure gradient force, that is related with high pressure and low pressure. As I told you, the wind moves from high pressure belt to low pressure belt. Second is the Coriolis force. This Coriolis force is generated due to the rotation of the earth. Due to this Coriolis force, the oceanic water deflects towards right in the northern hemisphere and towards left in the southern hemisphere. These two are in the syllabus, but third one, the frictional force, this is not given in the syllabus. But little introduction about this frictional force. How does frictional force affect the speed and direction of the wind? As you know, the horizontal movement of the earth, the horizontal movement of the air is not exactly horizontal movement due to uneven surface of the earth. Second thing, there are friction between the movement of air and the earth, because there are several features are present on the earth's surface. With those, the frictional force is exerted by the moving air. This frictional force reduce or retard the speed of the wind. If the frictional force is high, then the speed of the wind is low, and if the frictional force is low, then the speed of wind is high. Now we come to the physical feature also. The part of the hill or mountain that is faced towards the moving air. These things we understand in this way. The slope of the hill that faces to the wind is called windward slope, and the opposite face that does not face the wind is called lee side. leeward side. Leeward side. Windward side, there are two things, windward side and leeward side. The hill, the face of the hill that faces the moving air or wind, that is the windward side, and opposite of this, that is the leeward side, that does not face the moving air or wind.